Hello, it's Miss Cliffner with your video lesson about inequalities. And the essential question for today is how can we use a number line to represent solutions of an inequality? So I'm going to go ahead and jump right into the warm-up looks like this. It's a balance puzzle. I'm not going to solve it right now because I want to make this video as short as possible for those who missed the lesson. Okay, so here we go. There's our essential question again, and these are the symbols. You've already seen the greater than and less than symbols. We've worked with those a lot comparing numbers, but now we're introducing the greater than or equal to and the less than or equal to sign. And of course, it looks like they took the greater than and the less than and they smashed an equal sign up into it. So it can mean two things. So if you've ever gone zip lining, you know that there could be weight and height restrictions. So I want you to think about this. The maximum weight for zipping is 250 pounds. And then there's a minimum weight of 60 pounds. So it would look like this if I was going to write an inequality. I would say 60 is less than or equal to my weight, which has to be less than or equal to 250 pounds. So the idea is, can you weigh exactly 60 and ride the zip line? Yes. Can you weigh exactly 250 and ride the zip line? Yes. So now I set up two inequalities, but then I smash those together. I could just write one inequality like this and the second one like this to describe the weight requirements for the zip line. Okay, so now this is an example of the RPJ, and I'm just going to go over one so that you can see what it looks like. If your friend is more than 3 minutes late, the numbers that represent that statement would be a 4, a 5, or a 6, because it says your friend is more than 3 minutes late. So 3 is not included because 3 isn't more than 3. So the idea is you might notice that all of the numbers are greater than 3, right? All the numbers that I chose. You know, there's a bunch of little decimal numbers in between that you're not seeing. And then is the number 3 included? And I would say no, it's not included because it's not more than 3. But if I want to write some other numbers that would be included, how about if your friend was 3.2 seconds late? Or what about 3.5 seconds late? Or what about 10 seconds late? Right? Or sorry, minutes. Or 20 minutes late. Okay, so those numbers make this come true. And so what we're thinking about doing eventually is we're going to make a number line and we're going to show an arrow of all the possible numbers that make a statement true. Okay, I'm going to fast forward through this. So here we go. What's the difference between an equation and an inequality? So if I do something like this and I say 4 plus x equals 10, you know there's exactly one solution and it equals 6. That's the only number that makes that true. But what if I do this? 4 plus x is greater than or equal to 10. Well, 6 says 10 is greater than or equal to 10. But then I could pick numbers like 7 or 8, right? Because 4 plus 8 is 12, and 12 is greater than or equal to 10. So now I've got a whole bunch of numbers that can make it true, right? So the big difference is this. This has an inequality sign, and this has an equal sign. This has exactly one solution, and this most likely has many solutions, which is why we start graphing them on a number line. Okay, so here's the notes. You're going to write in an inequality, oops, I'm having a hard time writing an I. An inequality is a mathematical sentence that compares expressions. And we've got these 4 symbols to use, and notice you have a bunch of words to go with it. Let's move this here so you can see the words better. Okay. So I've got is less than, is fewer than, and I know you guys think about is fewer than as a turnaround word, but right now, as long as there's an is in front of it, it's not subtraction. It's now a comparison symbol. And what I want you to add to this list is right here, when I think about the zip line, when it said you can be at most 250, that is a maximum number. And then with this symbol, I abbreviated max, but I'll write maximum. And then this would be a minimum, right? You had to weigh at least minimum. You had to weigh at least 60 pounds in order to do the zip line. So all of these words is no less than, is greater than or equal to, that all means this symbol here. So we've got the words that match these new symbols, and that's what we're practicing today. Okay, so Remember, the crocodile still eats the bigger thing. And then, of course, to do a not equal sign, you just put an equal sign and you put a slash through it. Okay, so write in word sentence as an inequality, right? So that's kind of what we're doing today in the homework for some of the problems. So how I normally teach it, with just like words into math with equations, is the same for inequalities. I'm going to circle the number C. I'm circling the -4. I'm underlining is less than. And if you don't know the symbol, you look in your list and you go, oh, it's that symbol. That means is less than. So I write it like this. C is less than -4. Oops, my pen's not working so great. Okay, make sure that's is less than. All right, next. Number K plus 5 is greater than or equal to 8. I underline the plus. That means add. Is greater than or equal to, right? That one long phrase means this is greater than or equal to. This is not an equal sign, and then it would look weird to do this, right? You wouldn't do that. Okay, so K plus 5 is greater than or equal to 8. And then the last one is 4 times a number Q is at most 16. So I'm going to write 4Q is at most. Let's see. I wonder if that's a minimum or maximum, right? I can look at my list and I go, oh, that's a maximum. So I know I'm going to be writing it this way, is at most 16. Okay, so now there's some of the keywords of words into math. And then we've got some OYOs. So you go ahead and pause the video and try these on your own. And number N is greater than 1. Underline is greater than, and there's the symbol. N is greater than 1. Twice is 2 times a number P. Oops, I didn't mean to circle the twice. I meant to underline twice. It's a math word, not a number. I mean, it is a number, but it means 2 times. Okay, is fewer than is the less than symbol. So I say 2 times P is less than 7. And then number W minus 3 equal to 10. Minus is minus. It's not a turnaround word. Is less than or equal to. Looks like that. So I have W minus 3 is less than or equal to 10. Next, number Z divided by, there's my division symbol, 2 is at least. That's the minimum. And then -6. So I have Z divided by 2 is at least -6. Okay, so the other part of the homework and what you're going to need to do is when you have an inequality, there's a whole bunch of numbers that make it true. So you put it on a graph so people can see what it looks like. So the graph of an inequality shows all the solutions of an inequality on a number line. Super easy way to see what numbers make the equation true. So I want you to notice that there's open circles and closed circle. So if you just have a less than symbol or greater than symbol, the circle is open, which means it doesn't include that number. If you have an equals, that means it includes that number and it's a closed circle. So an open circle is not a solution. So it doesn't make it true, but it comes really close to it. And a closed circle is a solution. So here's an example that I would use. If you look at this one right here and you say, I want all the numbers that are greater than 2. Let's say you go to Legoland and there's a ride and it says you have to be older than 2 to ride the ride. Notice I didn't use at least. So usually rides aren't like that. But if it was, then if you were 2 years and 1 day, right, you're like right in there. That's an open circle, but the open circle would be right on the 2. Anything above 2 years would be included as a solution. So it's super close to 2, but it's everything bigger than that. I probably wouldn't get into hours, but you get the idea. And then if we start graphing inequalities, right, I look at the inequality, it says G is greater than 2. So if I put in my numbers, I'm going to do an open circle at 2, and then I draw an arrow to the right. And it's all of the numbers, right, to the right make the inequality true. Okay, so now I have some OYOs for you to try. And And so pause the video and try these. Okay, A is less than 4, so I'm going to do this. I'm going to do 2, 4, 6 on my number line. I'm going to do an open circle on 4, and then I'm going to do an arrow going off to the left. F is less than or equal to 7. I might go 5, 7, 9. This is a closed circle. Oh, it might be a good idea if I do a closed circle down here, closed circle, just to remind myself that which ones are open and which ones are closed. So this includes that number, so I do that. I put an arrow on the end, all those numbers. And then n is greater than 0. I could do -1, skip 0, 1. Here's the 0, open circle. I'm looking for all the numbers that are greater than 0, but not equal to. It's an open circle. And then p is greater than or equal to -3. I could do -3, -2, -1, 0. I'm going to go ahead and put a closed circle because it includes -3, and the arrow goes to the right, goes to where all the numbers get bigger. Okay, last thing I want to show you is checking solutions. Oh, sorry. Yep, that's it. Okay, so when we're checking solutions, the idea is I plug it in and see if it makes it true. So if I plug in 0 to this inequality, then in place of the x, I would put 0 plus 3 is less than or equal to 7. And then you ask yourself, is that true? Well, yes, 3 is less than or equal to 7. So I'm going to say, yes, it's true. And then what if I try to put in a 4? And if I plug in 4 plus 3 is less than or equal to 7. Is 7 less than or equal to 7? Yes, this one's also true. Now what if I plug in 5 and I write 5 plus 3 is less than or equal to 7? Is it true that 8 is less than or equal to 7? No, this one is not true. So I know that 0 is a solution, right? 0 is a solution. I'm going to abbreviate solution. 4 is a solution. And I know 5 is not a solution. Okay, that's it for today's video.